Sounds great, thanks.
Thank you. And we'll now move on to our next presenter, who's Zulkifly Abu Bakar from MCA Architects. Zulkifly is going to talk about a proposal to harmonize BIM and IoT data silos using blockchain applications. Over to you, Zulkifly.
Yeah, thank you, Ken. Yeah, thank you, everyone. And thank you very much to Sita for this opportunity. And I'm very happy to be here today. And okay, let me introduce actually myself. I'm Zulkifly. I'm currently taking a role as a BIM coordinator at MCA Architects. And I'm also currently a student and study artificial intelligence and machine learning at National College of Ireland. And today I'll be presenting my paper titled Proposal to Harmonize BIM and IoT Data Silos Using Blockchain Application that I do during my final year of MSc in Applied BIM and Management at TU Dublin that I finished last year. And first of all, allow me to thank you, Dr. Malaki Matthews, for as the co-author for this work, and also the supervisor. Thank you for his valuable knowledge, in particular blockchain field, and support and courage for me to do this presentation today. So a bit disclaimer before I start is all views in these presentations belong solely to the author and not necessarily to author employers, organization or individuals. So without further ado, in today's agenda, firstly, I want to give an audience an overview of the work, the research background. The first one, the research background covering problem, statement, and objective. Secondly, I want to discuss about a challenge of BIM and IoT data integration. And next, I will be briefly guide audience about what is blockchain and the key components or application. And finally, demonstrate with a proof of concept to demonstrate the blockchain capabilities. Okay, my research background, starting out with the problem statement. As we know, the integration of BIM and IoT in digital and physical world can provide a significant end-to-end benefit. But however, data silos, as you know, have impacted the integration process. This is caused by, for example, a disconnected system, like a centralized unintegrated database system across two or multiple repo. And next one, maybe because the industry running on the file-based system still, so it creates a data reliability and interoperability issues within the participants. And thirdly, and most important, is the security issues that I'll be covering. The security issues, current system were vulnerable to attacks and theft and malicious activities. So it's really hard to actually connect between BIM IoT due to these issues. So my objective is really aim to build a relationship between the shared environment within the BIM and IoT. And I try to use, as you can see in the anatomy of technology, I'm trying to use blockchain actually to secure the BIM and IoT environment by building a trust, allow data to be shared while providing reliability, security, and transparency, privacy for data owners, and maintain control their own built assets and access. And thirdly, I'm trying to creating a value, trying to leverage end-to-end benefit information provided by harmonizing data silos between the environment. So first, when we discuss about BIM, then the first place that we look is a common data environment, or the CDE. As part of digital evolution in the construction industry, the BIM or the CDE itself aims to change the dynamics and behavior of the traditional work process and how we share information. So the CDE constantly evolve and drive the AEC industry to the data-driven model. But the one thing, the question really, the issues of the current state of the CDE, does CDE actually change the way we communicate and how data is governed within the platform, the shared environment? So let's dive into the challenges, the BIM management challenges. If we look closely, the CDE composed of many parts, and most of them are unstructured and unconnected. Every day we're dealing with and receive many unstructured data. This includes emails, word processing, multimedia, etc., etc. And from many projects which are inefficient for the machine to digest, result the data sitting in unconnected silos, which has rising trust issues within the participants. And not many of the parties involved within the environment want to take their responsibility to the shared information due to the lack of clarity regarding roles and interoperability in the process. So this contributes to data redundancy and then easy to manipulate because of lack of control and such. The information received is also resolve intensive. Is actually very difficult for me. Day-to-day job as BIM coordinator is very difficult to create an audit table or access log, and it's also impossible to verify as the data grow. So next we discuss on the IoT challenges. In general, IoT is a system that employs interconnected smart devices like your smartphone or TV to transfer data using the internet. So IoT data, on the other hand, are very noisy because of the different types that transmitted from the various types of device and domains. And also IoT facing the vendor also now incentive to share the market and with the competitor. This create a data lock in silos issues and also cause interoperability issues, not only within the environment, but also outside the internet. For example, when you're trying to integrate with the BIM, for example. So that's the thing that we need to rethink with the integration. We need to actually consider approach that can establish the end-to-end collaboration via a single source of truth that can enable understanding, analysis, and informed decision making. And we're trying to transform unstructured data to actually a more structured data. So during my literature reviews, I have identified a couple of technology solutions, and one of them is blockchain technology. Blockchain technology is, as we can maybe heard, the image as a disruptive innovation to democratic data sharing. Maybe this is too broad in terms of definition, but let's see how the blockchain, what is blockchain, how it actually works. This is just a brief example. So first of all, blockchain is actually not cryptocurrency. So it's actually not a blockchain, not a Bitcoin. So, but no doubt the cryptocurrencies like the Bitcoin itself or the Ethereum has changed how we see money, perceive value, and ownership. For example, NFT, non-fungible token, how we can utilize for ownership, verify ownership. So blockchain is actually essentially a digital ledger to record a transaction. So actually, what is different between the traditional ledger and the blockchain? Firstly, blockchain using a hash function to make a transition difficult to tamper. And secondly, is distributed across a network of computers using a P2P network to share ledger. That means that it has a decentralized capabilities and distribute power away from central authority. The data stored in the blockchain is broadcast in the network, so anyone with a key to able to permit and verify the transition in the blockchain ledger. So these are the main components of the blockchain application, as we discussed earlier. The distributed ledger in the design to record transaction across the network of computer use a consensus mechanism. Actually, consensus mechanism is a agreement mechanism used by the network of computer to verify information in the blocks. The common type used blockchain technology is consensus is proof of work, but of course, the proof of work uses a lot of energy. But then again, there's 100 or more consensus that can use to actually use a zero energy. It really depends on how we design the work use case and how we use the technology. And last and most important component of blockchain is the smart contract. Smart contract, basically a segment of code, is a trigger when a a certain events is activated. So it's basically enable automation of data flow of information. Okay, so I just jumped through a proof of concept that I created. That I choose a very common use case. This, for example, I use for health and safety record. I try to demonstrate how to collect telemetry information and link the data in the distributed ledger and a BIM model. So for the solution architecture, I'm using the Microsoft Azure for building and managing IoT data and also managing a smart contract. So interconnected between BIM data and Azure platform is achieved within via Forge API, Autodesk Forge API. So I will jump through into the process. The first step I'm taking in creating the proof of concept is install a MX chip IoT dev kit with the temperature and humidity sensors to collect to provide a telemetry data for the BIM. So the next one, the BIM model will initiate to the web viewer to host the metadata from the digital assets. BIM model were altered in the Revit Autodesk Revit and used as a virtual twin. So the data from the IoT sensors then link into the digital model in the web by using a call function coded in JavaScript. So this bring all the 3D information and IoT application into the Azure IoT Hub. So the next, this is most important. This is where blockchain take a role with a web app setup and a smart contract then can be deployed. A smart contract is actually a piece of code that can automate a transition between the environment. So this contract enforces a specific function according to a parameter that are specified in the IoT device. So the humidity and temperature rules measurement are specified by the participants and deployed to the workbench, a blockchain workbench. The smart contract application was built to secure this transaction between the multiple counterparties at any given time. So the next, the function of logic apps is actually to automate and trigger the process. And upon finding a new message, the logic app is actually create a message and ingest the telemetry into the smart contract. Then this contract collects telemetry data, and then upon receiving and evaluating temperature, humidity data against agreed upon acceptable range. If the IoT device identifies that the telemetry out of acceptable range, the contract will shift into out of compliance and appropriate action can be carried out. So the last step is really the basic process in evaluating temperature data against is really benefit the user. This information can also be viewed and queried at any point in the blockchain explorer. So my findings with the proof of concept is really the smart contract records an agreement relationship between BIM and IoT. And the next one, blockchain consensus allow appropriate access to verified data. Then this can create a trust and distribute across multiple parties involved without this point of failure. And the third one is data transacted within the environments are validated and recorded in distributed ledger. This is the valuable assets for making a more accurate prediction and decision making. So, and after all, BIM and IoT is about connection, perhaps by emphasizing blockchain potential role in promoting better collaboration and integration between BIM and IoT environment would reveal the real benefit of leverage this technology, harmonizing data silos, encourage AEC industry to actually develop a more collaborative, flexible in a creative environment. And originality and value of building life cycle maybe can be redefined. Yeah. Thank you.
Okay, thank you, Zulkifly. Very interesting and lots of big topics including your conversation there. When we set up CETA 20 years ago, we were talking about data silos, and we're still talking about data silos. Obviously, technologies move on, but the interplay between technologies, people, and processes continue. And we probably have more data now to unsilo or desilo. I like the idea of we're dovetailed with Connor's previous presentation on that dynamic link and predictive analysis and so on. So I'm sure we'll have some questions maybe at the end, if that's okay, if you can wait until then. And we'll move on to the next speaker.